Okay, time for more nerd files. This time we need to talk about measuring skis, flex testing. Everybody who wants to get into working on skis gets into measuring skis. I measured many thousands of skis. I used to take my flex tester to the warehouses to select skis. At the time, part of what we were doing is trying to make sure the skis were well paired. This is quite a long time ago, and the pairing standards and the factories weren't very good. So part of the job of selecting skis was making sure that the pairs were good. That's so much less of an issue now because every company has really upped their game in pairing up skis and making sure that the tolerances in production are quite good. This was the system we used to use on classic skis. We would measure closing flex, 48.9 kilos. For me, that was the load in kilos required to close the ski to a residual camber of 0.2 of a millimeter underneath the load, positioned 8 centimeters behind the balance point. And then this +5 was the closing rate that we came up with, where we closed from 0.2 to 0.1 millimeter and looked at how many additional kilos it took. So a lower number meant that it was softer at the finish. And a higher number meant that it was stiffer. So we were looking at the rate in addition to the absolute value. Then we were looking at half weight values measured in a forward position, and we were marking the pockets at 1/10 of a millimeter, 15 hundredths, 20, 30, 50 hundredths, and measuring the residual camber, or the amount of camber that was open when the ski was fully compressed under the load. And we were measuring the back of the pocket by repositioning and loading the ski at 2/3 body weight in a neutral position about 15 centimeters behind the balance point. It was a protocol that we came up with that results in pretty much exactly the same marks that we do by hand and eye now. If you were measuring skis, you probably went further than that and started to look at contact points, glide zones, tip splay, all sorts of different camber measurements. And if you were really fancy, you came up with additional instrumentation to start to measure pressure profiles. We have a box full of instruments upstairs that we haven't reassembled that have a pressure gauge that moves along under the ski. And in the end, it all doesn't matter all that much because most everything that you need to know is built into the camber of the ski, and you can see and feel it really well. And quantitatively, the factories all do a really good job measuring their skis. When we're measuring skis, we're not measuring their stiffness, we're measuring how the camber gets expressed under load. So, we have a ski. Every one of these Solomon 201 universal classic skis is the same material and stiffness functionally. So they have pretty much the same bending radius up in the small material. They have the same thickness profile and therefore the same bridge stiffness. Materially, the stiffness profile along the length of the ski is going to be very consistent. And so what we're actually measuring with this closing flex value or any of the camber measurements are the expression of the camber. The ski has a shape, and we need to see how that starting camber shape expresses against the snow under load. Every company has an idea of how their skis should work, what the cambers should be. If you are the designer of the ski, the tester of the ski, the race department, you're servicing the race skis, all of this is all under your control, and then you're the one who goes to get and set the cambers and make the skis. You'd like to think that you could just produce great skis. But it's a factory. Skis are being made all the time. Skis are probably being made while you're asleep. So at some point you need to be able to say, hey, this is the set of characteristics we want, and you send it off to production, and there's a production department whose job it is to make really good skis. How do you tell them what they have to make? Every company has to solve this problem, and the ski measuring that happens in the factory is generally really focused on trying to produce the object that has the right set of characteristics. And when we talk about the right set of camber characteristics, we're talking about the camber working in balance. The back of the ski and the front of the ski need to work together. The camber has to express in balance. The high point of the camber needs to be in the right place at various different load states, and the ski needs to work at the skier weights required. And so the task of measuring skis is really something that needs to describe very much more about the ski than just the closing flex. That one number flex means nothing. It is the least effective way of quantifying a ski. Every company has a bunch more numbers. Fisher has, I don't know, I haven't really counted all the numbers, If we scan this two-dimensional barcode, you can see there are a bunch of other numbers that they're measuring. These all go into their pairing algorithm. It's an automated robotic setup for pairing the skis, and they're looking not just at the closing flex or the HR value or half weight. They're looking at the resting camber height and the bridge length at half weight and full weight. A bunch of different values go into that whole equation. Modsus is interesting. They have a really unique testing apparatus that's optical, and it can produce a curve, a continuous camber curve, and they measure, because the measurements are instantaneous, they being optical, they measure at a whole bunch of different loads. And so you see this half and full weight camber curve adjusting at different loads, and they actually can produce all of these bridge lengths at different loads. They can look at the angles of incidence, they can look at the progression of the contact points, the length of the contact points, all of it they can evaluate mathematically because everything is contained in a very, very large database. So they capture a massive amount of material information on the skis, and they've developed tools to help with production and in the race department to look at a whole series of skis. It's quite a powerful system. They just pass along relatively small amount of it. So when we look at Salomon, they provide us a huge amount of data here. This is pretty cool. The MF value down here is the mid-flex. That's the load required to compress to 0.2. You also have one for 0.3 and 0.1, so you can look at a loading rate like the one I was making before. The rest of these numbers are measurements of the camber and contact points and heights at a nominal load. Now here's what's interesting. Everyone in the industry has always in the past had to pick a set of loads. So Fisher, for example, has a standard load for their 207 length and another standard load that's lighter for their 202 length and another standard load for their 197, etc. The different ski lengths and models get compressed at different loads for measurement purposes. So for instance, this HR value on a 207 is measured at a higher load than the HR value on a 202. So they can't be compared directly. If you're a skier between a 207 and a 202, a 1.0 millimeter HR on the 207 is a different number from the 1.0 on the 202. It's a higher ski, all right? Modsus, of course, loads at a bunch of different loads and captures that all optically, so they have much more flexibility in terms of how they're interpreting things. Salomon has just undergone a change, and it really has resulted in some good qualitative differences. Now, let's re-examine these numbers. All of these represent quality control markers. When they're producing skis, all of these have to lie within parameters. Let's look, for example, at this P2 value. That is the length of the camber behind the balance point with full weight applied. Here's the problem though. If, for example, you're producing a really light 197 centimeter ski that is going to be loaded at a standard value of 55 kilos or 27 and a half kilos on the half weight measurements, that 55 kilo on a ski that's actually meant for someone who's considerably lighter than that is going to blow straight through this, and that value is going to be outside the range, even though the ski might be totally right. So one of the things that Salomon has just done is first measure mid-flex, pick a weight value for the ski, and then flex each pair of skis or load each pair of skis to an appropriate skier load for the mid-flex value of the ski in order to evaluate all the other numbers. So when they're trying to produce the same object scaled to different skiers, you should see a much more similar set of numbers. Under the current regime, if a number like that P2 value, for instance, falls way outside of range, we know that it's a bad ski instead of just being outside the range of appropriate values because the skier is on one end of the bell curve. It makes a really big difference to the production, and in selecting skis, we found that the production quality is more consistent and better. This is interesting because there's no change in the presses, in the personnel, in the method of manufacturing. It's all in how they're measuring the skis and how they're then working with the output to ensure that the product quality is really high. When we talk about measuring skis, the use of those measurements in manufacturing is really important. There's a lot of impatience in the general ski community that there's such a thing as good skis and bad skis. The companies all want to make all good skis. It's impossible. And the reason it's impossible comes back to the fact that skis are dynamic, and the smallest, tiniest changes to the shape of that camber can make a profound difference to the performance of the skis. We have learned over time to see tiny changes in the camber. We can actually see things more sensitively than we can measure them. We're using our hands and our eyes to a level of sensitivity that is very, very high, looking for exactly the qualities we want to find. But we would have much harder work, and we would probably have to go back to measuring skis to find pairs if the companies weren't all doing really, really good work measuring the skis themselves so that the production process has the right controls applied to it. It's really difficult to communicate exactly qualitatively what a ski should be. It's got to be communicated quantitatively. There need to be parameters that get worked against so that the production guys can change the screw settings and make the right skis. Every company has had to evolve their own process, and most of these measurements are really measurements that are used in that process. At any rate, we're many years past measuring every pair of skis ourselves. Having a standardized measurement that we use to compare skis from different brands is kind of beyond the point because the insides of the skis are so different. The material properties are different. The bending radius here is quite different from the bending radius on this Fischer ski, and therefore we need to pick a different set of tip splay characteristics. The ski has to be a different starting shape because the materials will express differently, and that's true start to finish along the length of the ski. So standardized measurements we're not taking. We don't measure our skis, we evaluate them. We evaluate them with a great deal of care. We do use the factory measurements. They're better than our measurements. Every factory has test skis where they've measured them a bunch of different times. Even there, in the same environment, in the same factory, under the same roof, at the same temperature, the skis measure differently every time they're put on a piece of flex equipment. The flex equipment needs to be calibrated. Fischer changed their flex measuring equipment last year, and all of a sudden their numbers all changed by about 10% because calibrations had wandered off. The same has been true of Matsus, that a change in calibration results in a whole different standardized set of numbers. When you start hauling test equipment around the world like I was, the hope for calibrating it or keeping even the benchtop perfectly flat is really out the window. You don't even know what you're measuring. Salomon has these incredible stone granite slabs that they're pushing the skis against because they're so stable. The equipment that's getting used in the factories is heavy, very well engineered, and as repeatable as you can possibly make it. Their numbers are great. So we have, in time, elected to utilize their numbers, learn their numbers, understand the system that's used internally to reproduce the skis, and work within that system to mine as much information as we can from the measurements we're given, and then use our assessment of the qualitative aspects of the ski to select the dynamic response and the camber characteristics that we want for the skier and the stated purpose of the ski selection. Speaking of dynamic qualities, this is a relatively new one. Both Matsus and Salomon have been printing some stickers with dynamic load response curves on them. These stickers are kind of similar. The Salomon one is really kind of best utilized to represent a range of appropriate skier weights. So this box right in here is going to tell you that someone from 75 kilos would find this to be a relatively soft ski, down to 69 kilos would be on the stiff end, given the coefficient that they want to see off that mid-flex ratio. With Matsus, this is a little more interesting. On a skate ski, they take loads starting down below half weight. This starts at 20 kilos with the ski at 5 millimeters of residual camber, and loaded up to like 65 kilos, and it's down here at like 1.5. And so this shape is actually quite an interesting dynamic load response curve. What I've asked them is to put a reference curve on. I want to see an average curve, at which point, maybe in a light gray or something, at which point I could interpret this relative to an average. Right now, it's really hard when I pick up skis with no context for comparison to know exactly what this curve means. But the information behind it is awesome. It's really, really good to have all these different load states. This could be amazing. This tool could become really useful if Matsus were to put that average curve on there. I talked with Connor about it. They might be able to do something. Yeah, we'll see. So that's it. ski measurement. Is it all clear now?